It's reflections, not rotations today. So a reflection is a flip. Remember, it's like looking in a mirror. It's going to be backwards. The line of reflection is what you flip it over. Or if it was a piece of paper, it'd be what you folded. You'd fold on that line so it folds over to on top of something. You guys put the iPads away. Line of symmetry is the same thing as a line of reflection. You guys remember what symmetry means? Same on each side, yep. Like a butterfly. Yeah. If you cut it in half, it'd be the same on each side. It would fold on top of itself. Okay. The line of reflection, usually it's going to be a horizontal line like when we have a graph, or a vertical line. Sometimes it is an angled line. Okay. Now, we do have a couple in today's assignment where you have to sketch the figure that it shows you and then reflect it over the line. If it's something like this, a lot of times people just sketch it and they go like this. That's not a reflection. This would not flip over on top of this, right? The way you do a reflection, if you're sketching it, is every single point is going to reflect straight across that line to the other side. So what you want to do is you want to go at a 90-degree to it, and you go on the same side, the same distance, and put a point. So then this one, go across the same distance, and again, it's just an estimate when we're sketching. But that looks like that would fold onto there. Then once you have your points, you connect them. And there you could see that if you folded this, this would fold down on top of that. Okay? So in this picture, the line of symmetry is the same thing as a line of reflection. Now, when we have it on a coordinate plane, which most of them are, when we take the test on this chapter, which we're just starting the chapter, so it's a ways away, they have these exact same problems like this on the test. You got to plot this point. J is 3/8, so you go over 3, up 8, and just label it J. They want it reflected in the y-axis. They don't say over the y-axis, it's in. It's like looking in a mirror. So in the y-axis, this is the y-axis, so that means it's going to flip over that. So you just count. It's 3 away, so the new one is 3 on this side. So you just label it J prime. Now I believe on the assignment they have you put the coordinate 2. That would be -3, 8 is J prime. Okay? For this one, we're going to reflect K is 7 over 4 up. In the line, X equals 7. Remember how to draw that line, X equals 7? Crosses the X-axis at 7. So this is the line X equals 7. Well, what's going to happen when you reflect that? It's going to stay right where it's at because it's on the line of reflection. Okay? So if you folded it, it would just stay right where it's at. So K prime is the same point, 7, 4. Just to show you another line that they have is Y equals X. Y equals X is just the diagonal, positive diagonal going this way at a 45. Because this is 0, 0, both X and Y are 0. 1, 1, 2, 2, Y equals X. Okay? If it were Y equals negative X, then it goes this way. It's the same one, but it's going down. Now, in order to do this one, say we had this point right here, A, and they wanted to reflect it, you just count with the diagonals. This one is 1, 2 diagonals away, and remember, because you got to go out of 90 to it, so A prime would be right there. Okay? So there is a shortcut for this if you remember it. You don't need to follow it, but what happened here is when we reflected in the y-axis, here's the original and here's the new one. Anytime you reflect in the y-axis, the y's will stay the same. The x's will just switch signs. Okay, again, something you don't have to memorize, it's just a shortcut if you can remember that. So if they flip it in the x-axis, if they reflect in the x-axis, the x stays the same, the y changes signs. Okay? No, it's not. This is what we talked about before. All of these translations are isometries. So this just is saying that a reflection's an isometry. You guys all remember what that means? Doesn't change size or shape. Lines of symmetry. They drew them in here for us. This oval has 2 lines of symmetry. A regular pentagon has 1, 2, 3, 4, 5. A regular hexagon has, you can go through each side, 1, 2, 3, 4, and through each vertex. 5, 6. So if it's regular, a regular pentagon has 5, a regular hexagon has 6. What's a regular heptagon going to have? Hepta has 7. 7. Regular octagon will have 8. A regular triangle? 3. 1, 2. So if it's regular, however many sides it's got, that has that many lines of symmetry. A circle? How many?
Infinite.
Infinite. An infinite amount of symmetry lines. It's just every line you can draw through the center. Now, here's a trick one. They have flags. If it was just a rectangle, this would have 2. This way and this way. Diagonal doesn't work because it wouldn't fold on top of itself. You know what I mean? Can everyone picture that? This point would come down here. So I think it's a Japanese flag. They put a circle in there.
Do you want to do it?
And they ask for the lines of symmetry. Some people get that stuck in their mind that there's a circle, so it's infinite. But again, it's a flag, so it'd just be 2. Boom. Okay? If it were a flag like this, I forget which flag this is, but it's something like that. How many lines of symmetry would that have? Just 1. Right through there. Okay?
Alaska.
Okay, so reflecting the points, all we got to do is put the point on there. A is 0 over 2 up, and reflect it in the x-axis. Here's the x-axis, it's 2 away, so A prime is down here. So A prime is 0 over 2 down. Then B is 5 over 1 up. Reflected in the y-axis, here's the y, so it's going to flip this way. It's 5 away, so you go 5 over here. So B prime is left 5 and up 1. C is -4, 3. The line x equals -3 crosses the x-axis at -3. So that's that line. So it just flips across there, so C prime would be right there. So C prime is left 2 and up 3. And then D is 4, 0. in the line y equals 2 crosses the y-axis at 2. So that would be this line. So D is here, it's going to flip up here. It's 2 away from that line, so you go 2 up here. There's D prime, which is 4 over 4 up. Okay, easy enough. Line, number of lines of symmetry, just 1 right there. You can't cut it this way because the top isn't the same as the bottom. Regular triangle, 3, square, 4. The 2 diagonals and then the 2 sides. Okay, now one other thing that's in their assignment that they didn't have on here, it's minimum distance. The problem I think they have in the book is they have a pizza delivery guy. So there's a street and there's a house here. And then there's a house here. And they're asking, where should the guy park on the street? So when he gets out, he walks to one car, delivers the pizza, goes back to the car, and then walks to the other house, and then back. So he can walk the least amount of steps? Not quite. So you need to sketch this. So when you sketch this on your problem, all you got to do is put the 2 points for the houses, roughly how they are, and then the road that he's going to park on. So what you do on this is you reflect one of these points. It doesn't matter which one. Use green. So if I reflected this point, it'd be right about there, right? And then if you connect the two, this is where they should park. Okay? It doesn't matter which one you reflect, because if I reflected this one, it'd be right about there. If I connect them, it goes through the same point. So that's why all you got to do is reflect one point, connect it to the other. So on this one, if this is the door here, it'd be right about, this is the line now that we're going over. So it's about that far away, be right about there. And then if I connected these, this is where you should park. The distance from here to here and here to here, if you added them up, is the shortest distance total than if you parked right in the middle or anywhere else. Okay, so everyone understand minimum distance? There's a one where you got to sketch, and then there's one where you got to actually put them on a graph. So it's like this. They give you 2 points. Like one is 4 over 2 up, and the other one is, we'll say, negative 2, 1. They're wondering where on the x-axis is the minimum distance point. So all you do is reflect one of them and then connect, and wherever it crosses, that's the answer. So 0, 0 would be the minimum distance point. Understand how to do that? Okay.